In this video we are going to study the characteristics or properties of vectors. There are 4 properties for vectors. Starting with the first property, it says vectors can be moved parallel to themselves. This is a vector A here. If I move this A anywhere, here, or here, or here, I'm moving it in the same direction. Nothing is changing. So this vector, whether it's here or here or here or here, it always represents the same vector A. Okay, so this is what we mean by vectors can be moved parallel to themselves. The second property says vectors can be added in any order. Here are 3 vectors A, B, C. I want to add these vectors. The way I add them, or the order I take, is not important. I will take first A plus B plus C, and to add them graphically I use the tip to tail method. This means that when I move the second vector B, I have to place its tail on the tip of the first vector A, this way. So this is B here. And the same thing for C. The tail of C must be placed on the head of B, or the tip of B. Those 3 vectors now are consecutive vectors. They are drawn head to tail. The resultant of these 3 vectors is drawn from the tip of the first vector to the head of the last vector. From the tail of the first vector to the head of the last vector here. And this vector is R. Okay? Now, if I consider another or a different order, here I took A plus B plus C in this order. I followed this order. Now I will do the same example but following a different order. Let's say B plus A plus C. Okay? Starting with B, this is another B, same as O. Let me undo this. I'm unable to, yeah, here, this is B. Okay, then A, again let me clone A, this is A. So again I follow the same method, head to tail. The tail of B, the tail of A must be placed at the head of B. And this is A. Now C, again, the tail must be at the tip of A. Here we go. So these are A or B plus A plus C. Now the resultant vector, if I take this vector here and I place it between the tail of B and the tip of C, it will fit exactly. So what does this tell us? It tells us that the resultant here and here is the same. Therefore, the order of addition is completely, what can we say, completely, or the adding vector is completely independent of the order of vectors. Okay? This is for the second property. Now with the third property, to subtract a vector, add its opposite. So far we learned how to add two vectors, not to subtract. We don't know how to subtract vectors. So what I'm looking for here is A minus B, subtraction. Okay? but we don't know how to subtract. So we can do a little trick here, which is changing the subtraction into addition, but taking b as minus b. So a minus b is the same as a plus minus b. So now instead of subtracting a and b, I add a and minus b. Minus b is a new vector, the same as b, but the only difference is in the direction. The direction of minus b is opposite to that of b, and the magnitude is the same. Here are a and b. Now I want to add them. First I have to reverse b to get minus b. So this is a here. Minus b is the opposite of b. So now this is minus b now. Okay? Now a plus minus b, using the head to tail method, I place minus b at the head of a. Okay? This is minus b. Now the resultant again from the tail of a to the head of minus b. I'm changing the color. So here we go. This is on. Alright? So all what we did here is changing the minus or the subtraction into addition and reversing the direction of the second vector. Okay? Now property number 4 says multiplying or dividing vectors by scalars results in vectors. Scalars here means numbers, real numbers. They could be positive numbers, negative numbers, any number. When you multiply it by a vector or divide by a vector, what happens? This is what we are going to see here. And to see what does this mean more, I will consider an example here. I will take an arrow. This is vector A. Now if I multiply this vector by a scalar, 2, let's say 2a. 2a now is a new vector. But there are common features between the two, which are the direction of a and 2a is the same because 2 is positive, and the difference is the magnitude. The magnitude of 2a has to be twice as large as a. So if I draw 2a, it will be this big. This is a, and this is 2a. So this is 2a. Now if I want to draw minus 3a, how do we draw it? Minus 3 means first the minus, and we have to reverse the direction of a. It has to be in the opposite direction. The 3 will be 3 times larger. So change the color to blue. 3a. So now the direction here, in the opposite direction. This is a, 2a. And it has to be larger. And almost 3. And you see here the direction is opposite to that of a. How about we take minus half a, or which is the same as minus a over 2. Multiplying a by minus half is the same as dividing a by minus 2. The same thing, minus half a will be half the size of a and in the opposite direction. So opposite direction and half size. Almost half size. This is minus half a. And so on. So we have to take care of the scalar, whether it's positive or negative. If it's positive, then the direction stays the same and the vector gets either or the vector is either enlarged or minimized. And if it's negative, we reverse the direction of the vector as shown here in this minus 3a. Okay? Those are the four properties of vectors. I hope you understood them all. Thank you so much, and bye-bye.